couple of things. I know that our chapters and things are all kind of spread out a bunch of stuff, and it's kind of tough to go back and forth in the calendar to figure out where everything's at. So remember, one of the things that we have on the web is that if you just click to I don't know why it's not working, but if you get to where it says more, remember where it says Old Algebra 2 book? Vaguely remember that? Click on where it says Old Algebra 2 book, and then it would say click here for old stuff. I would highly recommend using this one to find sections in the textbook because all the PDF files are located in one spot, okay? As opposed to having to figure out what ones go where. So here's all the different chapters. So if we want to look at something from chapter 13, you just click on 13. Shut up. Anyway, you guys stop using all the internet, I could probably get to it. And then there's all the sections. Yeah, right. The review, extra problems, all that kind of stuff. It's one of those things that it's probably quicker to go into that as opposed to some of the other stuff. I want to make sure I showed you guys that. Also, this test is multiple guess. I mean multiple choice. Yeah, remember, if you guess on the whole thing, didn't I show you this? If you want to get 40 out of 50 on a multiple choice guess, a multiple choice test, if you randomly guess those, your probability of getting a B is going to be 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 4, 6, 7, I think. But what I'm saying is there's a chance. If you take an educated guess, I'd say then you're probably about here. Sure. But if you think about it, you still got to do the work to figure out the answer. Don't you? Yeah, I think I told you guys. I don't know if I know I told one of the classes. I might have forgotten to tell you because I forget about you guys a lot. I'm old and cranky. What I decided to do with this second semester, since it's basically all the grades got to be done by the time I leave on that Thursday, I figured just by doing a multiple choice would be fine. So yes, ladies and gentlemen, it is 50 questions. It is multiple choice. I kept it at 50 questions because I'm lazy and didn't want to flip over the scan trying to re-scan it. Because I don't want to be that guy who's got to run Scantron through 4 different times because there's 180 questions. Oh, excuse me. What was I talking about? Anyway, so the chapters, like I said, are basically, we had some rational exponents. That was 7, I believe. 8 was exponential growth and decay, logs. Then we went to trig. Trig was 13 and 14. What didn't you have for the majority of trig? What do you have for trig for the final, though? So you have to think about what can and cannot be accomplished with or without a calculator, because I can still do questions you can't use a calculator because you don't know how to use the calculator to do certain things. You know, like point lies on the terminal side and things like that. So it's a lot of things that are in here. It's all mixed. It's a good mix. Graphing, you can still do graphing stuff without having to use a calculator. You still have to be able to figure out max, mins, things like that. You've got law of sines, law of cosines. Then we went and did, what was after that? Sequences and series. That was chapter 11, and then we finished up with probability, which was 12, correct? So 7, 8, 11, 12, 13, 14. That sounds about right. What's that? Oh well. Why, hello again. What we'll do with some of these things as we get going is this packet thing that I kind of quickly made. It's got plenty of problems. A lot of it's got all the answers and junk on there. Tomorrow, I know for a fact we're basically going to do trig all day. So then I'm just going to kind of walk you through some of the logarithm stuff, the exponential growth, exponential decay stuff. I will stop here. Okay. You can get up and charge your calculator. We'll all just stare at you for a second. Why are you walking around my classroom? Okay. Anyway, it's one of those days. Why are you staring at your calculator? You don't know what you're doing. Oh, okay. Anyway, so back to some of these things. Hey, what would you do to figure out which one is the right answer for number 1 and 2? I would use my calculator trying to figure that out, and then I wouldn't try to think. Now, when I get to number 3, remember what you've got. One of the things you could do, well, you can find the intersection of these two lines, these two curves. That'd be a pain in the butt. Or, if you think about it, remember, guys, it's multiple choice. You should never get a naked math problem wrong. The answers are in front of you. You have a calculator. You press buttons, you hit enter to see which one makes the same number. Or you remember how to math. So 1 over 625 is 5 to the negative 4th power. Okay? Over 5 to the 3a. When I simplify that, I get 5 to the negative 4 minus 3a, which has to equal 5 to the negative 2a plus 2. Are those two bases the same? What happens to the exponents? Correct. They drop, and you add 3a to one side, and you subtract 2, you get 6 is a. And you go to the next problem. Yes, please. How did I do that? I notice what I have. If you look at everything here, everything else is written in as a base 5. 625 is 5 to the 4th power. 625 is 25 squared. 25 squared is 5 to the 4th. Since it's a denominator, it's 5 to the negative 4th. Okay. Number 4, you got the same idea. You got 16. Guys, come on. So I have 16 and 64. Well, 16 is 4 squared, 64 is 4 cubed. So isn't that going to be 4 to the 2 times 3x equals 4 times 3 to the 2x. So that means 6x equals 6x. So that means that, what? All real numbers, good. Math. So 16 and 64, I'm trying to rewrite them as a common base. 16 is 4 squared. So power to power. So it's, well, I'm sorry, it's not power to power. So it's 4 squared times, and 3x is in the numerator then. I'm sorry, up in the exponent. So that's where I get 4 to the 6x. And on the other side, 64 is 4 cubed. So I get 4 to the 6x. Since they have the same base, exponents drop, and you get 6x equals 6x. Pick a number. I need an answer. Pick a number. Pick a number. 2. All right. Does 2 equal 2? All right. We simplified out and said x equals x. No, it's not C, it's a 2. Remember, Abby, you'll have the multiple choice. Press button. Seriously, you're going to surprise you how stuff like that. Don't overthink it. Logarithms. Remember, log base b of y equals x. So b to the x equals y. That's how you rewrite back and forth. So b to the x, so this would be log base b of 289 of 1/17 equals negative 1/2. Yes. Same idea, 14 squared equals 196. That means log base 14 of 196 equals 2. Yep. Yeah, because that's what they're starting. They're starting with exponent forms and then you're rewriting the log form. Expand each logarithm. Remember, when you're expanding logs, you're starting with log. I'm expanding it. Hey, that could be one of the answers. You never know how I think. Yeah, right. All right, so it's logarithms, when you have multiplication, means you add between the logs. Exponents means the number goes out in front of the log. So here you get log base 5 of 3 plus log base 5 of 10 plus 2 log base 5 of 7. Once again, the two went out in front of the log. Sorry, I didn't mean to get this out of the way. Shh, gentlemen. Ray, I threw one of these on your desk. I don't know if you had it. Yes, ma'am. I couldn't hear you. What? Nice. Please, for the third time, because jerks in the back are being loud. Yeah. Yeah. So if you skip down and look at the at 9, where it has 4 log 3 of x minus 16 log 3 of y, if you have to condense that one, doesn't mean to write it squishier. This means you have log base 3 of x to the 4th over y to the 16th. That's what that means. You change it to an exponential power. Something I would have said. I didn't pick up on that fast enough. Thank you. The cube root of something means it's to the 3rd power. If you look at number 10 real quick, when you have that log base 2 of 5 divided by 2, remember how the CUDA stuff does? That means this. That part is 1/2 log base 2 of 5. That's what that means. I know. And I was just saying that the cube root, that means if the exponent, change it right away as the x to the 1/3. And that 1/3 with the one from the log. And it's similar to what I'm going to do with this one here. This one here, you've got exponents and you've got addition, so you have multiplication. So what you would wind up with is a log base 2 of 11 cubed over the square root of 5. And that would be the, I'm sorry, not over. I thought that was a subtraction sign. My bad. That was the square root of 5. Or you might have written it as 5 to the 1/2 power. It means the same. Should you ever get an equation wrong, you have a calculator. Correct, but do you remember how to work backwards with exponents and things and stuff? It's okay. You're going to be fine. Here's a worry. Why? So it's like, oh crap. But logarithms and exponential growth and decay are all in chapters 8. Okay, so I'll remember to go through some extra stuff on it here in a minute. No, go ahead. I'm trying to avoid even. I will.
When you like change it to x to the 1/3, then would you just do it like number 7?
Yeah.
And then the answer is like in fraction.
That's okay. It's over 2. It's just 1/2 in front of the log. It means the same thing. It means the same thing. 1/2 times something is the same thing as divided by 2. Well, yeah. Except for being a 2 would be a 3. Let me show you. When you get that, you've got log base. I'll give 1 second. So all you wind up with is 4 log base 4 of x plus 1/3 log base 4. Oh, z. And they probably did this part all over 3. It's the same thing. We're just used to writing it like that. Yes, ma'am. Yeah. When you have 3 log base 2 of 11 plus 1/2 log base 2 of 5. There's addition between the 2, which means the 11 and the 5 will be multiplied together. So I get log base 2 of 11 to the 3rd power times the square root of 5. Gotcha. But that 1/2 out in front means the same thing as 5/2. That's why I want to make sure you guys saw that. Nope. What's that? Oh, you have to divide. Well, remember we did that with, what did we do that with? Exponents. Remember we had the negative number to an exponent? That means that if our answer was negative, it was an odd exponent. So the pattern that worked with geometric sequences. Remember we did that? Not in Smile. Just not in Smile, because we did just like, oh yeah, I remember that. Not a lot. We did a lot, didn't we? You start going, holy crap. All right. Multi-step equation. First thing you gotta do is add the 0.5 and then divide out by the -4. So if you add, yes, 3, whatever. So I'm going to add the 0.5, so I have -12 plus 0.5. I divide that by the -4. And right now I've got 14 to the 6x plus 1 equals 2.875. Are we okay with that so far? In order to get that exponent to drop, I have to take the log base of 14 on both sides. So I log base 14 of both sides. Log base b of b to the exponent drops, and I get 6x plus 1 will equal the log base 14 of 2.875. From here, it's easy. Type that in the calculator, subtract 1, hit enter, divide by 6. So what we have to do is alpha window 5 for our log base. We know it's going to be 14. Move it over, it's 2.875. Hit enter. Subtract 1. Hit enter. Divide by 6. Hit enter. Again, if you're using the calculator and you've got multiple choice problems, it's really quick to just put it in the calculator and just type it in. If you forget, if you're working backwards, you don't get something that works out cleanly. You just get crappy numbers. Alpha window 5. 11. That's pretty close. Yeah. Oh, I'm going to print out a copy of the equations for you guys, and I'll show you what it is tomorrow. Okay? I have them handwritten out. I just haven't typed it in. I'm going to do that tonight in printing. Oh, get there. What's in front of it that you can get multiplied by? -1. Multiply both sides by -1. Yes, sir.
You want us to round it?
It'll tell you. It's usually rounded to like the 100th or whatever. It's usually what I get. This one said the 10,000. It's pretty crazy. With the next one, you got -2 to the 3 minus x minus 7 is -37. Everybody okay? That first thing you got to do is add 7, and then you'd have to multiply by -1. Because when you add 7, you get -2 to the 3 minus x equals -30. I can't log base a negative, so I have to multiply it or divide by the -1. And then I get 2 to the 3 minus x is 30. Which then I log base to it. I get right to it, and I log base to it, making up lyrics to a song that I wrote. So I'm awesome. And then I press buttons again. Alpha window 5, that's my band name. The Alpha window 5 of the Mighty Mighty Asthmatodes. That'd be a pretty good band. Make a t-shirt. And then now 3 to the 3 minus x is going to equal this crappy number. So I'm going to move the crap and move the x. So all I have to do is 3 minus my answer. Oh. And you get 0 when you have answer minus answer. So 3 minus the 4.90689 Jenny, whatever. Inverses. Remember how to do an inverse? Yep. You flip-flop x and y in your resolve. For example, in chapters. If I want to find the inverse of y equals 2x minus 3, I would flip-flop x and y, and then resolve for y. Add 3, divide by 2, I get x plus 3 all over 2 is y. That means these two guys will be inverses of one another. But I'm not that nice. I wouldn't give you a linear equation. I'd give you crappy equations. Merry Christmas. Sorry, dude. So if I look at 14, I get y equals 6 to the x plus 8 all over -3. First thing I do is just rewrite x equals 6 to the y plus 8 over -3. And then I start working backwards. Work backwards from your order of operations tells you I have to take care of, divide by, I got to do that -3 first. So I multiply the other side by -3. And then I'd have to do what with the 8? Why, hello! What trig function do I use here? You are right. You may answer. You can throw this stuff on my desk. Then I would subtract 8. And this equals 6 to the y. And then how do I get that y to drop? I put a copy of this on your desk. Did I put a copy of it on your desk? And I log 6 it. And there would be your inverse. Yeah. That vaguely ring a bell now? No, you can do that one. These times. What do you do first? Switch them. Right. It's not hard. No. How do you undo taking a fourth root? You fourth it. Those are that's sectors in Arclight. Chapter 13, section 13.2. When you still had a calculator with trig. Try it. Come back to it. Log equations. Log equations are also just as quick and painless with any luck. For example, if I'm looking at number 16, fishing season. So when you're working with log equations, again, same idea. You work your way backwards. Subtract 1, divide by the -3. And then how do I undo the log base 12? 12, yeah, you 12 it, yep. Exponentiate it with a 12. And then you get 7x plus 5 equals 1, 1, 4. Then you get some crummy number. So let's see. Alpha window 1/144. I have to subtract 5, hit enter, divide by 7, hit enter, and I get -719/1008. Love that answer. It's a great answer.
I don't like that answer.
-12 to the -2. When we got this part here, we have, I had to, hey guys, when I have the log base 12, in order to get this part undone, if you will, remember we had to exponentiate it, we raise it up. If I do it to here, I got to do it to here. So I get 2 to the negative, or 12 to the -2, which is 144. If you wanted to leave this, if you just type that into your calculator, Maria, if you just did, if you knew that you were going to have 12 to the -2, subtract 5 all over 7, you could throw this right into your calculator. You don't have to break it down into small parts. Correct. Yep, sir. Correct. That is called the regular base of log. Hey, just in case you didn't know, log without a number is log base 10.
What does it stand for?
What does what stand for? E? It's log base E. Log base E, no. Wait, log base E is natural log. I forgot that. You might. Because you know how hard it is to find all these problems? I can't give every problem on there. It's in that chapter. Well, what chapter was natural log and exponential stuff? It would be the ocho. So I wonder where I could find ocho problemos. In the ocho stuff. So, and what I would suggest, I would roll through some of the chapter review stuff. Go back through if you forgot. Yes, sir. Equation? Yeah. Give me one sec. When we get into these, one of the things that we did do a ton of, remember we did exponential growth, exponential decay, compounded interest. monthly, continuously, things like that. I will give you those equations, but I will not tell you what they are, just like I did before. Okay? Nothing for you. Welcome.
So did you just say that they're not?
I said log without a number is log base 10.
So you're saying you're giving us the equations, but it's not really. You trying to just tell me.
Maybe. Yeah, what happens is when I was trying to build something like this, it's pretty crappy about anything with a word problem. So I wanted to make sure that we talked about that as well. But before I get into the word problem, I'm going to do another one of the quick log equations, and I'll come back to this. Okay?
I got it somewhere.
Which one do you want to look at of those? So if I look at 17, I got negative 5 log base 3 of 8, negative 8x minus 6 plus 5 is negative 5. Now, what I have to do here is I got to start peeling back to get to the log by itself. So I'm going to subtract 5. So I get negative 5 subtract 5, I get negative 10 equals all this junk with the negative 5 out in front. Okay? How do I move that negative 5 then? I divide by the negative 5, good. So then I get log base 3 of junk equals 2. What trig function do you use? Yeah! Good work. You saw my best. So now we're at log base 3 of negative 8x minus 6. To get rid of the log, I exponentiate it with 3. So then you wind up with negative 8x minus 6 is 9. Add. All right. Poor Abby up here is just all kerfuzzled about number 13. I don't know why. So this one is kind of a smidge on the ugly side. Not like really, really ugly, but kind of ugly. This is 13 to an inverse. So I've already flip-flopped my x and y, which means I got to start peeling backwards. So how do you undo a fourth power? You fourth it. So I fourth both sides, and I'm going to get x to the fourth equals 3 to the y over negative 2. And now I have to move the negative 2 over. And then to get the y to drop, I have to log base 3 it. Oh, I see what you're saying. Then you'd have to put this as a negative 1, I believe, out front. Is that what they did? I thought that's what that was. I didn't realize it was a negative there. What was that, 13? Oh, they left it at that. Yeah, they left it at that's a negative 2. I know what you're getting at with the negative there. Technically, yeah, I'll make sure. I see what you're saying. I can't use it. And if it's a negative number, it becomes positive, though. That's the thing. Yeah. But it's not all, it's just the x value to the fourth, not the negative 2. Yeah, this is fine. I would make sure, I didn't realize this when they spit this one out. They're just assuming they're just trying to rewrite. I would make sure that was just a regular, so you wouldn't have to worry about that negative there. So that's what you're getting at. No, yeah, because you can't take a log of a negative. Yeah, that's all. I think it's what you get. Yeah, because it's symmetrical and it gives you the thing across y equals x. Yes, ma'am. Yeah. Yep. And remember, a lot of times if you get rambunctious, you want to verify it, you just substitute in one for the other, and if it gets y equal, if you get like y equals x equals x, you're fine. Yes, sir. No, because I made sure that mine all worked. Because I've taken the test twice. I did. I only got one of them wrong, I think. And I fixed it. Oh, back to those review jump. When we did the whole exponential growth, exponential decay stuff, we had a whole bunch of formulas. And exponential growth, exponential decay formulas, I'll give you them. I'm just going to tell you which ones are which. Okay. If I'm not mistaken, growth, decay, and PERT, the compounding continuously, those are all in the very first 3 sections of chapter 8, 1, 2, and 3. They're all mixed in there. So if you have to go back to remember, oh, what does the decay formula look like? Well, there's your decay formula. What does the growth formula look like? Oh, it was a plus in between the two. Oh, what was the compounding? Continuously. Oh, that's your PERT. And if you're compounding monthly, they had a whole other formula. So I'll give you guys a copy tomorrow of what the formulas you'll get will look like, so you can kind of use that in it. Yeah. So you can read all over it. Absolutely. That'll give you a fresh copy on the test. So for this one, it's a depreciation. So it's going to be your overall amount, 1 minus the rate. And what they're asking you here is the value of a new car purchased at 24.9 depreciates at 10% a year. Write the model and figure out how many years it would be until it gets half of the purchase price. So you're trying to figure out when this is going to equal half of 24.9. Half of that is 12,450, I believe. Okay. The A stands for the initial amount, so it's going to be 12,450 equals 24,900. 1 minus 0.1 to the t. So in this case, you can math all you want to it, or just use your table function in your calculator. Because remember, this is multiple guess. This is multiple choice. So you're going to have, after so many years, to figure out where does it work. So if you use your y equals, if you throw this into your y equals and then look at the table, you will see that it happens after, I think this one happens after the second year. Okay. Or if you solved it, you'd have to divide this by, you know that 1/2 has to equal 0.9 to the t. Well, 1/2 is 0.5. How do I get that t to drop? I log base it. So I can log base 0.9 of 0.5 to get t. You can do it a couple different ways. A lot of times people are a little bit more comfortable looking at the table as opposed to pressing buttons. The other one was, I think the other problem I was going to show real quick here was a compound. 7% interest compounding continuously. Compounding continuously is the PERT. So this is your principal e to the RT. That's for your continuous. Otherwise, the other one I believe was A1 plus R over N to the NT. There's a button. So if you want, you deposit $4,000, e to the rate, which is 0.07 for 5 years. You put that in the calculator. Your E button is right below the log button, so you get second natural log to get to your exponential. Yes, ma'am. Continuously. Continuously, because there's an E in it, that's why there's an E in PERT. Continuously, E, continuously, E, it's an E sound. Continuously, I know, but it's an E sound. It sounds like an E. It's a sound. A Y can make it sound like an E. So, and that's why there's an E in PERT. Because PY in the RT is this one. It looks like a PAR T. Paul's like, what the hell is going on? What's up? It depends on if it's compounding annually, that means the number of times it compounds in a year is 1. If it's monthly, the number of times would be 12 and so on. Yeah, they'll say compounding weekly, monthly, something like that. Yes, sir.
Where's the
E button, right above the actual log, so this would be 4,000. E to the wrong button. After 5 years at 7% interest, you will have $5,676.27. Yes, ma'am. Yes. Yeah. For the card depreciation, like this one, did you put all that in? This tells you after how many years. Hey, we're gonna get tricky with it tomorrow as much as we can. Nah.